Hi everyone. Good evening and welcome back to this week on AWS Cloud Path. We haven't met in like 2-3 weeks thereabout. But if you've been following us, you know that we are currently working on a networking workshop from AWS Workshop Studio. And this is where we are at. This was where we stopped last, the clean up section of the multiple VPCs subtopic. And I hope that we are able to finish the rest of the foundational topics today, and we'll be moving on to the advanced topics. So the remaining foundational topics include security controls. That's the network access control list, security groups, endpoint policies. These are things that we've worked on loosely, but not like focus on particular security requirements or meeting some constraints. And connecting to on-premises, establishing a VPN connection, like exploring hybrid environments, hybrid DNS, and the network monitoring using CloudWatch and VPC flow logs. Like these are the two main services that you can use in monitoring your AWS environment. Okay, so let's get started with security controls. If you are joining us starting now, you may want to go back to the prerequisites section and deploy the CloudFormation template in your AWS console so that everything that you need to have set up is already set up. I'm not sure if I put it down during my cleanup session, but we can have a look together and I'll show you where to check to make sure you have it set up. Okay, so you want to check your CloudFormation and you should see the stack. Yes, I have put it down, so I'll need to redeploy it also. So let's do that together. You want to download this CloudFormation template. I think the instructions are pretty clear in the prerequisite section, but download the CloudFormation template. You'll come here and you would create a new stack with resources standard. New resources standard. So we have an existing template that we're going to be using, and I think that's the only upload the template file. So I'm going to choose the file. What was that just now? Yes, multi VPC. So that's what I'm uploading here. Click next. The stack name, I'm going to use the stack name that they have here. So there's one part here that I want to reiterate. Like, I'm working in the Europe region, that's the Frankfurt EU Central 1 region, and my availability zones, I'm going to be picking them in EU Central 1A and EU Central 1B. The workshop is using US East 1 region. So you may see the default parameters here as US East 1A, US East 1. So whatever region you are using, make sure to check that you are picking the availability zones in your region. Yeah, and that is all, I think. Check our IP address. put that there with the 32 slider mask, like /32 at the end of it. And okay, just checking to see that we're not asked to modify anything else in the stack. Go down to this page, click next. We're not changing anything on this page, and yeah, I think we can create it. Nothing else. Submit. So we have to wait for this to deploy. There's something that happened. It's unable to deploy this. I'm guessing that so it's possibly because of maybe some resource that I created in the past one. I didn't remove it completely. So this is VPC B NAT Elastic. I think this is the Elastic IP for the NAT gateway in VPC B. We'll see what. Let me go check it. Maximum number of addresses has been reached for the Elastic IP. Let me check it. That would be, let me see, the EC2 Elastic IPs. Yeah, they're here. Let me see what this is for. Okay, so these IP addresses, I'll just delete them. I released the IP addresses, the Elastic IP addresses, and then I would retry the deployment again. So I think from there we can continue. Yeah. Okay, rollback complete. Come on. I'll just redeploy it. Choose an existing template, upload template file. I'm just repeating the exact same steps we did before. Next, this is EU Central 1A, EU Central 1B. I'll just go and delete this one. That's Okay, so we can use this name without any issues. That's just why I deleted it, because I want to use the name. Oh please. So my region, EU Central 1, EU Central 1A, EU Central 1B for my availability zones. The IP address, you would want to go and check this. And check IP, Amazon, and whatever results you have here, copy it. Yep. So we're just going to proceed as is for everything. Next, and submit. I don't expect any issue to happen again with the Elastic IP addresses, since I already released the ones that were already existing, and we shouldn't have reached any limit with the Elastic IP address allocation. But we watch and we wait. Okay, looks like most of the stuff is already created. Where are we at? Still in progress. Okay, let me go back to where we are in our stack. So what we are deploying now is not only the basic like prerequisites that we used to start, is essentially deploying everything that we had done up until this point and preparing the environment the exact way we built it before. We couldn't leave it running because we had some things set up that would incur costs over time. Yes, so once this is done, we should have 3 VPCs, like this exact architecture here. So once this is done deploying, we should have 3 VPCs. VPC A, yes, I think VPC A, VPC B, and I see another VPC B. They have different IP address ranges: 10.0.0.0, 16 mask on the CIDR block. The other one starts from 10.1.00, and the third one starts from 10.2.00. We'll see everything, yes. But as you can see, they all have like 2 availability zones. They're deployed in 2 availability zones. Everything, they have 2 private subnets, 2 public subnets, each of them. Yes. And there is the internet gateway. This one you can see. I don't know if you can. Yeah, this internet gateway to each of the VPCs. There's the NAT gateway, this you can see here, in each of the VPCs in 1 public subnet. And you have an EC2 instance deployed in the public subnets in VPC A, and another one in private subnets. You have, it's just some deployments already set up, yeah. So we'll look at it closely. And our stuff is still being created. Just go to the next one. Okay, I wonder now that we spent like 20 minutes cleaning up and preparing the environment, if we were able to finish all the foundational topics. But there are topics that we have tried to touch. I would of course go over them as quickly and as detailed as we can. Network access control lists. And you know what? One of the topics that we always have is network access control lists versus security groups. Like there are people that ask a lot of times, like Why can't you use network access control list to limit your stuff, your access, or use security groups to limit your access? Why do you need both of them? And would be seen in detail like how we can be really flexible, like manipulate the different network access control list or security group to really work together to meet our constraints and our goals. Okay, so it's good for a layered approach to use it together. Yes. I'll just go back here. Yeah. So we've compared some of their very detailed features, but one of the most notable ones is that the network access control list is stateless while the security group is stateful. What that means is that for your network access control list, you allow or you block whatever like IP address range, and it doesn't take note like when a particular like traffic goes through, it doesn't take note or remember, okay, this one is allowed in, so when it's coming back I'll let it out or something. No, you have to explicitly define all your rules per time for each entry or for outbound or for access allowed or for access denied. Everything has to be explicitly stated, like with network access control list. Whereas with security group, yes, you need to explicitly state your access, but what happens is that if you allow traffic into your security group, automatically it's allowed back out. Like it's stateful. You don't need to put another rule to allow that same traffic out of your security group. I'm not sure if that makes sense to you now. But if it doesn't, of course, we would look at it closely. Yes. And I know that in security groups, by default, everything is denied. Yeah, I think by default, everything is denied. So whatever you want to allow, you have to, grant access to allow it. Okay. Whereas in network access control list, you can explicitly deny. But in security group, you cannot be writing like deny rules. Everything is denied by default, so you allow what you want to allow in. And we are still creating progress. I think it's a really huge deployment we're having. 100 plus resources that are being deployed in our environment. Make sure to pull down everything when you're done, okay? And let's continue looking through this. So here I said that network access control list, the rules are numbered lists, and you evaluate it from beginning to the bottom. If a rule is matched, the rule is executed and that's it. It doesn't check everything below it. So the order of your rules, is that like the numbering of your rules matter a lot in your network access control list, because if you put the wrong rule before the other one, it's going to be executed before they even get to check the rule you want them to check. So it's numbered and there's a deny all at the end. Yeah. And this works for both incoming and outgoing traffic in your network access control list. Like when you look at the rules for your network access control list, the inbound rules, the outbound rules, you can configure them like exactly the same way you configure inbound rule, you configure outbound rule the same way. So same thing, the rules look the same. I mean, yeah, it's just maybe the destination is different and all. And when you create subnets, that's the subnetworks in your VPC. By default, the network access control list, that is the default in your VPC, is going to be attached to your subnet. Yeah. And you don't want to be using your default network access control list. You don't want to do that because, of course, the security is trash. So you configure your network access control list for the subnets that you're working with, and then you attach them accordingly. For instance, the network access control list for your private subnet would not be the same for a public subnet. You get the security requirements are different. Yes. So in this section, we'll be modifying the network access control list on these VPCs that are deployed in this setup. So VPC A, VPC B, and VPC C. Okay, it's not VPC A, VPC B. That would have been confusing actually. So we have 3 VPCs, A, B, and C, and we'll be configuring them to be able to work together. Modifying the rules in our network access control list to allow connectivity between the subnets. So I'm sure some of them would have been created anyway, but right now we are still in creating progress. So let's move on. So default network access control list configuration for your VPC. Let's go to the VPCs. It's still not fully deployed, as you can see, creating progress, but I just want us to start looking at what exists in our environment. So we can see here we have 4 VPCs. You should also have 4 VPCs. This one that has the blank name is your default VPC that comes with your AWS environment, and you don't want to use that to do important projects at all. I said why in previous videos, but I will repeat that it can pose a lot of restrictions for you when you're deploying important projects in your default VPC, especially when you want to allow connectivity between this VPC and another VPC and another account and all that. You can't really do some connections or pairing or some things with your default VPC in the AWS environment. So yeah, these are the 3 that we just created: VPC A, VPC B, and VPC C. So the first task we'll be having is configuring our network access control list for VPC A as this one. Yeah. So we'll go look at it and then we'll see what they need us to do. So to go to your network access control list, on the sidebar, let me make this bigger so you can see everything. Yeah, I think this is better. On the sidebar here, under security, here, you'll see your network access control list. And yeah, there are multiple network access control lists. But here we are asked to go for VPC A workload subnets network access control list. It exists here. We're going to click it, and you see it's down here. Currently, it's associated with 4 subnets. Okay. Everything in VPC A, all the subnets, private subnets, public subnets, in both availability zones, everything is associated with this subnet. Yeah. And this, it says it's not the default. That's what this default no or default yes means for the network access control list. It will tell you whether for the VPC that is specified in this VPC ID, whether this is the default network access control list for the VPC. So we'll go to inbound rules, and we can see this is the inbound rule. Yeah, this is the inbound rule that is currently set up here. And this is what I meant when I was saying like the rule number determines in which order your rules are executed. Okay, so all traffic is evaluated for protocol, port, and source IP match. That's what you have here: your protocol, the port range, and the IP. No, this is, yeah. the source IP. This one is for the destination IP. So we're going to be modifying the rules to match what is in the workshop. I'll explain the rules as much as we can. So we'll be editing the inbound rules. While we're doing this, let me just pop in here to check if our stack is fully created yet. Not yet. Okay. We continue to watch. So as you can see, we cannot modify the last rule, but the rule 100, we're going to modify it to allow all ICMP IPv4 traffic. There is already like some preset types that you can use here. You don't need to cram some ports. Like you'll see, okay, MySQL Aurora is 3306, or like, yeah, you don't need to cram some particular types of traffic. Custom ICMP, no, we're using all ICMP IPv4. So what this is it allows all this ping and tests, like communication connectivity between networks, like between your resources. The source is 0.0.0.0/0, which says anywhere, so allowing this ICMP, all of it from anywhere, and that's what it is by default. But we want it to be from VPC biz CIDR block range only. Currently this is from anywhere, but we don't want from anywhere. We want it to be VPC biz CIDR block. This is it. But you could also check it in your environment. Oh my, there was an error with this. It's going to delete everything again. I really hope it doesn't. A moment, let me have a look at this. I wonder what the error was this time. There's an EC2 instance. The instance profile, it was not able to create it. The instance profile. Oh, okay. I wouldn't want us to spend today trying to fix the deployment of their CloudFormation templates and all that, but I would still want us to look through the workshop, even though I most likely will not be deploying this stuff, but I'll explain everything. Yes, so that we can wrap up the foundation now topics today and move on to the advanced topics next week. So this stuff is with the deployment in the CloudFormation stack, the templates, not the workshop itself, like the things we are trying to do. If you did it with us manually, you probably wouldn't have this issue. You'll be able to just continue. But because we're deploying all the resources from this stack and saying the network instance profile in the parameter is invalid. Okay, but back to what we were looking at. I'll just walk you through everything else. I won't be deploying stuff, but we'll be trying them out. So from our architecture diagram that I showed you the other time, I was calling out the IP address ranges for the different VPC environments for you, and this is the one for VPC B. For VPC A, it is 10.0.0.0/16. VPC B is 10.1, same, and then VPC C is 10.2, same to the end. And when we now say we want to allow 10.1.0.0/16, that restricts it only to traffic that comes from the VPC B IP address range. So for those of you that are just joining us, we were going to fully deploy this, but I had to put a hold on that now because the CloudFormation stack that is deploying the prerequisites keeps running into issues with some parameters in our template. So we can't set up the existing environment, but I'll still walk you through all the things that are in this particular section of the deployment so that we can wrap up the foundation topics and we'll be moving on to advanced topics next. So yes, if you're following, you can save this now and it would update your rules. Okay, so we would be going on to the VPCB and VPCC. What we have modified was the VPCA network access control list, and we allowed traffic from VPCB. But knowing that we didn't allow any other traffic, if you try to access it from VPCC, it should match this second rule, that is the deny. Okay, so if we allowed VPCA and VPCB and we allowed VPCC, then all of them will have access. But right now, if you are going to be testing this, your VPCB should be able to access instances in your VPCA if you have the testing connections, and VPCC should not have access if you have your testing connections. So this is how you test it, but of course we won't be testing it. So you go to your EC2 instance or whatever resource that you have deployed in your VPCB, and you should be able to ping to your VPCA instance, your resource in VPCB trying to ping your resource in VPCA, and you should get results. Like there is a screenshot here, I think, yes. So yes, so this is the command. To retrace what we have done, or what we theoretically did, was to go to our network access control list in VPCA, modify it to allow connection from the IP address range of VPCB. So now you launch an instance in VPCB environment that has the IP address from VPCB, you understand that? And when you launch that, you log into the instance via your connect and you run this ping command. You should have a result that shows that it is able to reach it, and it gets like the results, the ping statistics that shows, okay, 0% packet loss, this amount of packets were transmitted and all that, showing yes, it worked. Now that shows that, okay, your rule in your network access control list actually is giving you the results that you want. But when you test this exact same thing from your instance in your VPCC environment, remember that we did not allow any rule for VPCC to access our VPCA. If you try this same test to launch your instance in VPCC and put that command, you should have something like this, not a result that has 0% packet loss and all the packets that were transmitted were received and all. No, this one is going to give you 100% packet loss, saying this did not go through, we were not able to reach it, everything got dropped and all. That's what you should get from VPCC. So this was just testing, okay, connection deployment and all that. And I would be moving on to the next important place that I want to point out to you. Security groups, yes. So security groups, as you can tell, it doesn't look like this in the configuration of the security group rule. So let's go to security groups. There's a default security group here that we can look at, but if you have your set up, you can look at the exact one that's the configured here. So originally here we are supposed to modify the security group that is on the private AZ1 server to allow only the ICMP traffic from VPCC. Remember that currently the things that we are modifying is TVPC-A resources, and we tried that, okay, we want to allow VPC-B in the network access control list. It's worked, we tested and it worked. Just imagine with me. Okay, and you have your VPC-C that we didn't allow the access control list to test, and it didn't work. But at the end of everything, we allowed, okay, the VPC-B and VPC-C access in the control list, and we saw that, okay, both of them now work. There were no restrictions on the security group level to say, okay, you access this, you don't access this. That's why we could easily just change rules in the network access control list and see the results that we wanted. All right. Now, if you want to go further and restrict access even on the security group level, that's where it gets interesting. Now, I'm saying this because of here. Look at this. I want us to look at this. I want us to look at the diagram very well, and I'll tell you what I want to put out here. So, looking at this diagram, this is VPC-A that we are trying to restrict access in and restrict access to and all. Yes, you can see there's a server here in a security group. You can see there's another server here in a security group. Yes, and you can see all of them are using the same default network access control list. Can you see this green border here saying all of them are using the same network access control list? So the subnets, all the subnets, public subnet 1, public subnet 2, private subnet 1, private subnet 2, they all have the default network access control list of their VPC, just one network access control list to all of them. But we could go further and restrict particular resources even within the same network access control list restriction. We could still go further and restrict particular resources by attaching security groups to them, basically putting them in a group of resources that we put the same security restrictions on. Now, in this situation where we have now allowed access in the network access control list to say, okay, resources from VPC-B can access the resources in our network access control list, everything in our network access control list. And resources from the VPC-C can also access everything in our network access control list. How can we go further and restrict which of the resources they can access? That's where your security group comes in, okay? So even if you have the same network access control list to control access in your network, you could have particular restrictions on particular resources. Now, what I'm trying to say is this security group can allow, say, ping access, like you can use ICMP traffic, everything from VPC-B and not allow VPC-C to ping it. It can allow maybe, what do they call this? Database connection from VPC-C and not allow from VPC-B, or like you are able to now even go further in adding that layer to your resource security. You have your network access control list configured with rules, and then you have your security group configured with its own rules also, and that's how you're able to achieve that. So yes, we're done looking at this. Okay, so that's what the next series of steps or instructions are going to be doing. And even though we would not be running them, we can still have a look at them. I won't be able to show you in this environment, but I could show you exactly how some things look like. So here they are going to be modifying the security group on the private, this name of it, I think VPCA private AZ1 server, like the instance that is deployed in the private subnets. So we want to go and check the security group. VPCA security group. So essentially going to go and modify the security group on it. And as you can see, I'll just use this one as a sample to show you what the rules look like. Inbound rules. I can put this away. Yeah. What an inbound rule looks like. It just looks like allow all traffic. This one, outbound rule, allow all traffic. And you can edit, let me see here. So it looks similar to what we were setting up with the network access control list, where you can specify what type of traffic and the source of the IP of the connection. Maybe you want to use some IP address, your own IP and all. So it looks the same. The only thing that you will notice here is that we don't have numbers like the network access control lists. Remember that one had like numbers, like the rule we were modifying was number 100. That was the number of the rule. And based on how you number your rules, it would process them in that order. And when it sees what matches, it just stops and it doesn't continue. Now, security group does not work like that. We don't have numbers to order the rules. How security group worked is it picks the most specific match. I think that's the way it's always referenced. The most specific match. Now I will explain that. Our VPC is we have the IP address range. It's a big relatively big space that has a range of IP addresses for all the things you can deploy in it. And then inside our VPC, you have the subnets that is also smaller, but it has its own range of IP addresses for everything inside it. And then you can have even security group, which is smaller. And so the point is, all these IP address ranges, they have different sizes. Like, okay, this IP address range is like 65,000 IP addresses that I am putting this rule for. And then I have another rule that matches maybe 30,000 IP addresses. But this IP address that is currently trying to access my resource falls into, say, that 65,000 range. It also falls into the rule that has the 30,000 range. It also falls into the rule that has like difference. It matches them all. Security group is going to pick the most specific. That's the smallest range that matches, and it's going to execute that instead. So if you are allowing access from your VPC, you're allowing access from a subnet in that same VPC, you're allowing access from this, it's going to go to the very, very specific match. It can find maybe a rule that has exact IP address match, and it's going to use that one. If not, it's going to use maybe the one that has maybe smaller, maybe 3 IP addresses, maybe 5 IP addresses. Like it picks the most specific one, basically, yeah. And that could look different in many ways. I think that's the best way I could explain it. Yes. So you cannot use numbers to order your security group, but it's how specific your rule is that determines if it gets executed as expected. So you don't want vague, bogus rules in your security groups. Leave that to your network access controllers. In your security group, you want really fine-grained access in your security group. If possible, specific IP addresses. If possible, a small range of IP addresses. Okay, I only want access from this other security group that I've created. I only want access from... So, basically, allow as specific as you can in your security group so that you won't have issues with, oh, this is supposed to work, or why did this other one get executed instead? Nah. Okay, I think we can continue. So yes, the workshop is going to be modifying security group rules to allow connections from the IP addresses in VPC-B, VPC-C, and testing it all over again, the same way we did for network access control list. We won't be doing that, of course. I think we've covered the most important points in network access control list and security groups. And yes, this is all just changing things to make it. But I sincerely hope that the most important points in configuring network access control list, configuring security groups, you've been able to grasp them, and you can use these different solutions together as you would need them to work for your security constraints, for your security requirements, and get the results that you need. And yes, this is the last one in this security controls, and that would be endpoint policies. So endpoints, as I said before, like attaching them to your VPC allow direct access to AWS resources that you didn't deploy in your environment. Like how would I put it? AWS managed resources without having to go through the public internet. So, for instance, you're not the one that deploys S3. You just have an S3 bucket here. S3 is for the storage service, and you are able to access your S3 buckets privately without having to go through the public internet if you attach an S3 endpoint to your VPC. So using endpoints in your VPC can help you, also cut costs, improve your speed, like latency is reduced because you are going to be accessing directly in the AWS environment without having to go through the public internet. So that's all better. And endpoint policies are attached to VPC endpoints to restrict or grant permission to the calls, to the API calls. So it's going to be I want to see what we can do since we didn't deploy this particular I think we can still work with it. I would explain to you what this is the endpoints. We don't have any endpoints deployed yet. Okay. But when you create an endpoint, let's say there are different kind of endpoints you can create. But the ones that we are going to be talking about are the AWS service endpoints. There are AWS services, like we said, we want to be able to access them within your AWS environment without having to go through the public internet here. And when you are creating endpoints, you pick AWS services, and there's a lot of different AWS services that you can select. So depending on the ones that you have picked, you would be able to access this service without going through the public internet again. Now, there are two main types of AWS service endpoints. There's the interface type and there's the gateway type. For the gateway type, we only have DynamoDB and Amazon S3 that can use the gateway endpoint type. The other ones only have the interface endpoint type. And I want to just repeat what this entails. We've discussed it in previous sessions, but the interface endpoint type, you have to configure like some like network interface advanced configurations if you want. Like maybe you want it to have an IP address that you want it to use in this particular availability zone. Maybe like it's just like literally having a network interface, but the gateway does not have those configurations. It doesn't. And yes, so when we're talking about the endpoint policies, we're talking about the IAM policies that we have been looking at before and attaching them to your endpoints to restrict who can access it, or to say in which way they can access it. Like, okay, they should only access it if they have this constraints in their connection, if they fit this rule, if they match this condition, and all that. So that's what the endpoint policy can help you do with your endpoints. So let's look at what's okay. This is just testing connection. What they are doing here is testing connection from the VPC address, the VPCC, to your endpoint. But we're not testing that here. So we want to look at the endpoint policy in particular. And let me see the VPC3 endpoint. We've not yet created our own. We're going to create it. I'll just name it something. Test S3 endpoint. So we can actually look at the policy document. And the VPC, I will use VPC A still. Oh no, let me put VPCC just for. I'm adding it to all the root tables. So what happens is if you don't add it to the root table, it won't be available for your resources to use, because they won't find it. Anything you create that you want other resources to have access to, you should make sure there is a path for them to be found. You check your root table. If it's able to be routed to them, then fine. So I'm just going to add it here just for adding sake, yeah. And yes, this is where you can modify the policy. Right now, it's full access. Full access means allow access by any user or service within your VPC using credentials from any AWS account to any resource in this AWS service. All policies, everything basically is going to work as long as this is full access. If there are other policies, maybe the person does not have access to use S3 or whatever, it won't work for them. But as long as the person has access, as long as the resources are not restricted, as long as everything is working, if you allow full access, then they have full access, basically. Normally, I usually use full access for my S3 endpoints, but in your particular situation, you may need to restrict access to your endpoint. That's when this will work. So I'm going to create this, just to create it first with the full access. Okay, the VPC I selected does not exist. Let me refresh it. I'm going to use the VPC here, my default VPC. This one should work. Yes, so this is our endpoint, and we can see the policy here is allow all. It looks like the IAM policy that we usually use. So currently the statement is effect allow, principal all, action all, resource all. Allow all principals to perform all actions on all the resources that have this endpoint. So what they want now is to modify the policy to restrict the things that can be done. Yeah, so we can edit this policy manually, or you can decide to use this policy creation tool and you can easily select, oh okay, this is what I want. You can check the actions. It's more interactive, I would say. SQL policy, VPC endpoint policy, and you're able to just basically interact with it and select. This may work more for you if you don't know the exact thing you want to write in your policy, but you know the permissions you want to allow or something. You can use this. So back to this. Yeah, we're going to add the statement ID. This is not a requirement, but sometimes you may have multiple statements in your policy and you want your statement ID. So this is SID, and I'm naming it read write access like they did. And the effect is still allow. We're allowing all principals, but we're not allowing all actions. We're changing this one from all actions. We're changing it to this S3. So all the S3 gets, and all the S3 list. So this itself is not a particular action, but it includes a range of S3 get actions. So S3 get object, S3 gets bucket, anything that comes after get is going to match this asterisk. Same thing for list. Anything after list is going to match this asterisk. So it just includes all the list actions. S3 list object, S3 list bucket, like that. And we're allowing all resources. So this, I don't know why they called it read write access, but this looks only like read access, if you ask me. You're only able to get and you're only able to list. So there's no right here. But yes, let's just go with what they named it. Yeah. So this is read access. Why are we even going with what they named it? I'm going to name it read access. If we come back and modify to grant write options, I would add it. But this is read access. So we've modified this policy now, and it's going to be restricting what can be done with this endpoint. If you're trying to write and you're going to it, it's not going to allow it. So we have that, and I think that's for Alice. Yeah. Okay. So we can end this here. I would say that would be all. This cancel, and this should be all for the security part of this. So if you deployed anything in the course of this, please make sure to delete it. You can clean it up. If you deployed the template, you just go to CloudFormation and you click delete. It will delete everything. And yeah, that will be all for the security controls. This connecting to on-premise and network monitoring, we'll still have to continue it, but I just want to cross-check which we would need to do. Okay. This is what we'll be deploying next. There will be the same setup plus an additional separate VPC that is going to be acting like the on-premise environment, and we want to actually establish connectivity with this. So what I would do is I think I would make sure to deploy the CloudFormation templates ahead. Or what I would suggest, if you are interested, is I would go live 30 minutes earlier next week and actually start to deploy the CloudFormation templates online. I expect that some people would also have the issues. That's why I want us to dedicate some time to do it before time. But I don't want this to be during our session so that we can have it. So if you are not interested in deploying the CloudFormation template together or setting it up, then you can just join right at 8 p.m. next week. But if you have issues deploying your CloudFormation template, or you actually want to watch the fixing or the things that we have to correct, rectify in the template, then you can join us next week 30 minutes earlier. I think that would be the best to do it live, because I'm trying not to set up things or do things separately by myself offline, so that we can see the issues together and run into them, fix them, and have the real life experience. Okay, then I wish you a nice evening. Thank you for joining us this week, and bye bye.